Hey there, kiddos. In this video, we're going to go over lesson 5.6, which is all about scale drawings. Now, in scale drawings, we're going to be able to, or in this particular lesson, we're going to be able to solve problems that are involved in scale drawings. The criteria for success are going to be, you can find an actual distance off of a scale drawing. One, you can explain the meaning of a scale and a scale factor. And then lastly, you can use a scale drawing to find the actual lengths of areas and real life objects. So, keywords and vocabulary to remember: that a scale drawing is a proportional two-dimensional drawing of an object, whereas a scale model is a proportional three-dimensional model of an object. Scale: the measurements in scale drawings and scale models are proportional to the measurements of the actual objects, and that the scale gives the ratio that compares the measurements of the drawing or the model with the actual measurements. What does all of that mean? Well, that means that if we're looking at the ratio of A to B, that it's going to be equivalent to 1 to whatever B is divided by A. And so the scale is going to be written as a ratio where the first unit is 1, and then the second is going to be our scale model. So let's actually see what that looks like. So finding an actual distance. What is the actual distance between Cadillac and Detroit? So if we're looking at our map here, step 1 is to identify what we're looking at. So Cadillac and Detroit. Step 2 is use a centimeter ruler to find the distance on the map between Cadillac and Detroit. And so when we measure, we see that the distance is roughly 3.5 centimeters. Now, what is our scale? What does that mean? What does 3.5 centimeters mean in regards to this map? Well, if we look at our scale here, it says that for every 1 centimeter, that's equivalent to 50 actual miles in real life, if you will. So in IRL, it would be 50 miles for every 1 centimeter that we see on the map. So we're going to use that and write a proportion to solve, or use that ratio to then write a proportion and solve for our unknown. And so on the map, we see that 1 centimeter is for 50 actual miles, and we just measure that the distance between Cadillac and Detroit is 3.5. How would we then solve this? What have we done in the past that allows us to solve this type of two ratios that are being compared? Well, hopefully you said we can use cross multiplication, the cross products. So if we cross multiply 50 times 3.5, that's going to be equal to 175. So the distance between Cadillac and Detroit in IRL is going to be 175. And what are the units? Well, they're miles, so it would be 175 miles. Take a moment and pause if you need to just take a look at what did we just do? How do we use the scale? How do we use the measurements or the distance between whatever we're measuring? How do we set up the ratios of those two measurements? And then how do we use cross products to find out what the actual distance is in real life? Excellent. Let's take a look at another example. And as we see here, we use cross products. If you're a kiddo who you rather use a table to figure out what the missing value is, you could do that as well. We're multiplying by 3.5. 50 times 3.5, as we just saw, is equal to 175. Great. Let's take a look at example number 2. Example number 2, finding a scale factor. We're told here that a scale model of the Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. What does 1 inch represent in the model, and what is the scale? Well, the ratio of the model to the actual height is 10 inches to 100 feet. Now, as we said before, to figure out what the scale is, we need to figure out what is that going to be equal to in terms of just 1 unit. So we're going to divide each quantity by 10 to determine the number of feet that's represented by 1 unit, in this case, 1 inch on the model. And when we do so, we see that 1 inch represents 10 feet. So what is the scale factor of the model going to be? Well, one inch represents 10 feet, and we just want to make sure that our units are correct. And so 1 foot is equal to 12 inches. So that means 10 feet would be equal to 120 inches. So 1 inch on the model is equal to 120 inches in real life. So the scale is going to be 1 to 120. Once again, what we want to remember here is we want to pay attention to the order. Since we're going from model to real life, we want to make sure that those units remain the same. Okay, so when it comes to scale factor, we want to keep those 2 points in mind. The 2 points being, one, we're paying attention to the order, what comes first, and then secondly, as we just saw in part B here, if our units are not the same, meaning they're not inches to inches or feet to feet, miles to miles, we want to make sure that we're converting them so they are going to be comparing the same units to units. Alrighty? Cool. Now let's get to our classwork and actually our project that we're going to be working on.